Just imagine how cool it will be to just take a picture of an object and have it in 3D to insert in the movie or video game you are creating. This is what Google is working on. This is What's AI, and I share artificial intelligence news every week. If you are new to the channel and want to stay up to date, please consider subscribing to not miss any further news. Neural scene representation from a single image is a really complex problem. The end goal is to be able to take a picture from a real-life object and translate this picture into a 3D scene. It implies that the model understands a whole three-dimensional scene or real-life scene using information from a single picture. And this is sometimes hard even for humans, where the colors or shadows tricks our eyes. Oh, and not only that it needs to understand the depth in the image, which is already a challenging task to do, but it also needs to reconstruct the objects with the right materials and texture so it can look real. You can just imagine how cool it will be to just take a picture of an object and have it in 3D to insert in the movie or video game you are creating, or in a 3D scene for an illustration. Well, I am not the only one thinking about all the possibilities this type of model could create, since Google researchers are looking into this in their new paper, ShaRF, Shape Condition Radiance Field from a Single View. And you are seeing the results they could produce since the start of the video. Note that for each of these results you saw, they only used one picture taken from any angle. It was then sent to the model in order to produce these results, which are incredible to me when you think of the complexity of the task and all the possible parameters to take into consideration just regarding the initial picture, such as the lighting, the resolution, the size, the angle or viewpoint, the location of the object in the image, and etc. If you are like me, you may be wondering, how are they doing that? Okay, so I lied a little. They do not only take the image as inputs to the network, but they also take the camera parameters to help the process. Their algorithm learned a function that converts these 3D points and 3D viewpoints into an RGB color as well as a density value for each of these points, providing enough information to render the scene from any viewpoints later on. This is called a radiance field, taking positions and its viewing direction as inputs to output this color and volume density value for each of these points. It's very similar to what NeRF does, which is a paper I already covered on my channel. Basically, in the NeRF case, the radiance field function is done using a neural network trained on images and the intended output. This implies that they need a large number of images for each scene, as well as training a different network for each of these scenes, making the process very costly and inefficient. So the goal is to find a better way to have this needed radiance field composed of RGB and density values to then render the object in 3D in novel views. In order to have the needed information to create such a radiance field, they used what they call a shape network that maps a latent code of the image into a 3D shape made of voxels. Voxels are just the same as pixels but in three-dimensional space. And the latent code in question is basically all the useful information for the shape of the object in the image. This condensed shape information is found using a neural network composed of fully connected layers and followed by convolutions, which are powerful architectures for computer vision applications since convolutions have two main properties. They are invariant to translations and use the local properties of the images. Then, it takes this latent code to produce this first 3D shape estimation. You would think that we are done here, but it's not the case. This is just the first step. Then, as we discussed, we need the radiance field of this representation using here an appearance network. Here again, it uses a similar latent code but for the appearance, as well as the 3D shapes we just found as inputs to produce this radiance field using another network referred here as F. Then, this radiance field can finally be used with the camera parameters information to produce this final render of the object in novel views. This was just an overview of this new paper. I strongly recommend reading the paper linked in the description below. The code is unfortunately not available right now, but I contacted one of the authors and he said that it will be available in a couple of weeks, so stay tuned for that. Please leave a like if you went this far in the video. And since there are over 80% of you guys that are not subscribed yet, please consider subscribing to the channel to not miss any further news. Thank you for watching.